So today we're going to talk about the volume of cones. Now, if you watched the video of me comparing a cone to a cylinder, you would see that it takes 3 cones to fill a cylinder that has the same radius and height. So when I think about the volume of a cone, I realize that the formula for the volume of a cone is, let's change that pen. The volume of a cone is the area of the base times the height, all divided by 3. So the volume equals pi r squared h, which is the formula for a cylinder, divided by 3. You could also, for those of you that like fractions, you could write it as the volume equals 1/3 times pi r squared h. Either one of these will work for you. Okay, so when I think about a cone, I have the radius. Remember that the base of a cone has the same shape as the base of a cylinder. They are both circles. So what shape is always the base of a cone? It is a circle. It doesn't matter if I'm given the diameter measurement or the radius, because I know that the diameter is 2 times the radius, or that the radius equals 1/2 of the diameter. Those are just basic circle knowledge, I guess. So what is the formula for the area of a circle? Hopefully you have this committed to memory by now. The area of a circle is pi r squared. Why did we divide the cylinder formula by 3? Well, if you watch the video or if you just listen to what I said, it's because it takes 3 cones of the same radius and height to fill a cylinder. That's why. Okay. So I think we also just need to revisit, in case you didn't watch the last video, how do I find circumference? Circumference is pi times diameter, or more importantly, circumference is 2 times pi times r. Because if you're given the circumference of a cone, you could find the radius. All right, so let's do some examples. All right, so we are going to find the volume, and we're going to give our answer in terms of pi and rounded to the nearest tenth. I think it's important to be able to know how to do both. Sometimes you're going to be asked to give your answer in terms of pi, but sometimes you're going to be asked to give your answer to the nearest tenth or 100th. So it's good to practice both. So just like when we were finding cylinders, I'm going to write down my given information. So I am given that this has a diameter of 4 feet. That means that the radius is half of the diameter, or 2 feet. This cone has a height of 9 feet. So the volume equals pi r squared h divided by 3. I'm going to plug in my values. So the volume equals pi times my radius, 2, squared, times my height, 9, all divided by 3. Now the cool thing about this is that I can take 9 divided by 3, and that equals 3. So the volume is pi times 2 squared is 4 times 3. So the volume is 12 pi feet cubed. I also need to give this in terms of nearest tenth. So 12 times pi is about 37.7 feet cubed. So these would be my 2 answers. Let's look at example number 2. This cone has a radius of 5 inches, and it has a height of 12 inches. Using the formula of volume equals pi r squared times h, all divided by 3. Plugging in the numbers, pi times my radius, 5 squared, times my height, 12, all over 3. Again, I'm going to simplify. 3 will go into itself 1 time, 3 will go into 12 4 times. So when I reduce this, I have pi times 5 squared, which is 25, times 4. So my volume of my cone is actually 100 pi inches cubed. When I turn that into a decimal, that's about 314.2 inches cubed. So both of these are my answers right here. All right, we have a couple of word problems because you know real world applications involve word problems. So find the volume of a cone whose base has a circumference of 18 pi and whose height is 24 centimeters. So I need to find the radius first, and then I can find the volume. So I remember that the radius can be found using the circumference formula, 2 pi r. I'm going to divide both sides by 2 pi. And I discover that my radius is 9. 18 divided by 2 is 9. So that is my radius. So now I'm going to use the formula to find the volume. Pi times r squared times h all over 3 equals pi times my radius, 9 squared, times my height of 24 all over 3. And again, I'm going to simplify. 3 will go into itself 1 time. 3 will go into 24 8 times. So I really have pi times 9 squared is 81 times 8, which is about 648 pi. What are my units? Centimeters cubed. If I put this, oh, this one says leave your answer in terms of pi. So I don't have to change that. So there we go. Question number 4. Consider a cone with a radius of 15 inches and a height of h inches. So we're trying to find it. This is for the cone. And it has the same volume as a cylinder with a radius of 15 inches and a height of 45 inches. So you can do this one of. So when I find the volume for my cylinder, remember the volume of a cylinder is just pi r squared h equals pi times my radius, 15 squared, times my height, 45, equals pi. Let's see, 15 squared is 225 times 45. 225 times 45 is 10,125 pi. So that is the volume of the cylinder. Now it says that the volume of the cylinder and the volume of the cone are the same. So that means that the volume of the cone has to be 10,125 pi. Set that equal to the formula for a cone, which is pi r squared h all divided by 3, and plug in the values. Remember, we're solving for h. So I have 10,125 pi equals pi times my radius, 15 squared, times h, we don't know what that is, all over 3. So that becomes 10,000. I'm just simplifying. 125 pi equals 225 pi times h, all divided by 3. I'm going to figure out what 225 divided by 3 is. 225 divided by 3 becomes 75. So now I have 10,125 pi equals 75 pi times h. Divide both sides by 75 pi. Divide both sides by 75 pi. So I get h all by itself on this side, and 10,125 divided by 75 is 135. So the height of the cone has to be 135 inches. Now, that's the hard way to do that. The easy way would be to think about, well, let's see, if they both have the same radius, that means that their base area is the same. And if their volume has to be the same, I know that a cone has 1/3 of the height of a cylinder, or 1/3 of that. So if I take 45 and divide it by 1/3, we don't really divide fractions. Instead, we multiply by the reciprocal. I find out that it's 135. Wow, awesome. Okay, that's it. So you have a worksheet that's attached. Actually, you have an edge elastic assignment. Good luck. Let's see, this cone has a, whoops,